I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss about the topic Laplace transform of derivatives and integrals, multiplication and division by t to a function. We are going to discuss about in detail Laplace transform of derivatives, Laplace transform of integrals, Laplace transform of multiplication by t to the function f of t, Laplace transform of division by t to the function f of t. That is, if f of t is divided by t, how to deal the problem. If the function f of t is multiplied by t, how to deal. The integrals, how to find, how to use Laplace transform. The derivatives, the differentiation, how to use Laplace transform. First, the definition of Laplace transform. Let f of t be a function and defined for all positive values of t. That is, here the function f of t is there. It has the variable, the function in terms of t, it is there. The t is taking the value, positive values. Then the Laplace transform of the function, that is our f of t, which is denoted by L of f of t. That is Laplace transform of the function f of t. We can write L of f of t, otherwise f bar of s also we can say. So now L of f of t, which is equal to f bar of s, in simple way we can express about this Laplace transform. That is the function f of t, which is multiplied by e power minus st, and we will do the integration with respect to t from 0 to infinity. This integral, it should exist, and this parameter s is a real or complex number. Now, we will concentrate one problem, that is the function which is multiplied by t. That is, it is given L of t sine 3t cos 2t. Evaluate. So solution. First, the equation which is given t into sine 3t into cos 2t. First, we are going to concentrate only sine 3t and cos 2t. That is L of sine 3t and cos 2t. If it is only L of sine at, that is Laplace transform of sine at, if it is there alone a single term, then the formula which is available a by s square plus a square. If it is L of cos at, it is there, the formula s by s square plus a square. But the trigonometric functions sine and cos, they are put together combined by multiplication, sine 3t into cos 2t. So the relevant combined, the trigonometric functions Laplace formula, it is not available. Then how to proceed if the trigonometric functions under the operation multiplication, if it is there, Is there any relevant trigonometric formula? It is there. Suitable applying Laplace formula. We have to think first. In that way, the trigonometric formula which is available now, 2 sin A cos B, that is sine of A plus B plus sine of A minus B. This trigonometric formula, A is nothing but 3t, that is, we are comparing this trigonometric formula to our given problem. Here 2 sin A cos B is there, whereas here only sin A cos B it is there. The 2 is missing. That is the reason multiply and divide by 2 with it. Fine. So sine of A plus B plus sine of A minus B. This formula we are comparing with our given question. A is nothing but 3t, B is nothing but 2t. So we substituted in the formula, that is, this 1 by 2 it is written as it is, L of sine of A plus B, that is, our A is 3t, so 3t plus sine of 3t plus 2t. So we got it, sine 5t. Next, sine of 3t minus 2t, it's nothing but sine t. So now L of sine 5t plus sine t. L of Laplace transform of two functions. One is sine 5t, another one is sine t. So Laplace transform of two functions. If it is alone L of only one term, one trigonometric term, sine 5t, yeah, the formula which is available. But L of 2, it is not at all available. Then we will take help from the property, linearity property. According to that linearity property, L of C1 f of t plus C2 g of t, which is nothing but C1 L of f of t plus C2 L of g of t. That is Laplace transform of two functions, which is nothing but Laplace transform of first function plus Laplace transform of second function. The constants we put it C1, which is multiplied by those Laplace transforms. So linearity property, we used it, we found this one. So now, so this L of sine 5t plus L of sine t. This 1 by 2 it is written as it is. So the 1 by 2. So L of sine 5t, it's nothing but 5 by s square plus a square. So a square, it's nothing but, according to here, 5. So 5 by s square plus a square. Formula is sine of at, L of a by s square plus a square. According to our problem, a is 5. It's fine. That we got it. Next, L of sine t. Here a is 1. So a by s square plus a square. A square, 1 square, it's 1. So completely we did the Laplace transform of, in the question is completely 3 are there. t, one is t, another one is sine 3t, the third one is cos 2t. Now time being, we are concentrating only sine 3t and cos 2t. We concentrated and we got the result. This result we got it. So that is nothing but L of f of t. L of f of t, we can write it f bar of s. So only up to here we concentrated and we did the Laplace transform, we applied it. But our question is, this sine 3t and cos 2t, which is multiplied by t, then the next step we have to go. So it is written now. So now this entire thing, we got this is the result. And if it is multiplied by t, that means the t power is 1. If it is t power 1, we can see the formula minus 1 d by ds of f bar of s, because it is t power 1. Suppose in case, this is according to our problem, t power 1. In case instead of t power 1, the question is given t square, then how we can write it? So minus 1 the whole square d square by ds square f bar of s. If it is t cube, minus 1 the whole cube, 3 times we will do the differentiation. We will come back to our problem. Ours is t power 1. So that is the reason minus 1 into only one time we will do the differentiation into f bar of s. This part already we did. Now this minus this f bar of s, we got it 1 by 2, 5 by s square plus 25 plus 1 by s square plus 1. So this minus 1 by 2. This part we have to do the differentiation. So easy way the differentiation. The down part is s square plus 25. The numerator is 5. The 5 differentiation is 0 minus. The numerator is 5. The down part we will do the differentiation. S square differentiation is 2s divided by s square plus 25 the whole square. So it is written minus 10 by s square plus 25 the whole square. Fine. The next here, the similar way we can do this differentiation. That is s square plus 1. The numerator is 1. 1 differentiation is 0 minus the numerator is 1. The down one we will do the differentiation 2s divided by s square plus 1 the whole square. So we got it minus 2s by s square plus 1 the whole square. So now minus into minus plus 10 divided by 2, we are getting 5s. Minus into minus plus, so 2 cancelled, s by s square plus 1 the whole square. So we completed the first problem if the function f of t is multiplied by t. Now, if the function is divided by t, then how to deal it? First, the given problem is, this is f of t, the numerator we are taking, that is divided by t. We have to find Laplace transform of f of t by t. First, we will concentrate this numerator, that is f of t. That is our f of t is 1 minus e power t. Fine. This is also now Laplace of transform of 2. First term is 1, the second term is minus e power t. So the two functions, 2 are there. Laplace transform of 2. We can separate, we want to write. Each should be written in separate form of Laplace transform. The property is linearity property. That's what here the property should be written. According to this linearity property, this is Laplace transform of 1 minus Laplace transform of e power t. So this L of 1, it's nothing but 1 by s. Here this minus is minus. L of e power t, so the formula which is available, L of e power at, it's nothing but 1 by s minus a. 1 by s minus a equal to f bar of s. So this part, only the numerator we concentrated, we applied the Laplace transformation, we got the result, this one. Now we will concentrate, complete the entire question. That is L of that numerator, the problem numerator, 1 minus e power t is divided by t means how to do. So now our question is, L of, yes, this numerator part, it's nothing but just how to do it, L of f of t for this numerator part. This t purpose, which is integrated s to infinity dt. That is s to infinity L of f of t, it's nothing but f bar of s ds. That's what written here. Everywhere the Laplace transform, if it is multiplied by t or divided by t, we will apply Laplace transform for f of t. And after applying, if it is divided by t, the result, we will do the integration with respect to the t we are doing, that L of f of t, it's nothing but f bar of s. Because after applying Laplace transform, we know it, the result will be in terms of s. That's what here, f bar of s ds. Then from s to infinity. This part already we got it. That is 1 by s minus 1 by s minus 1 ds. Now we have to do the integration. The integration is the integral ds by s, we know it, it is log s. Yeah, fine. This minus is here. Now integral ds by s minus 1, that is log of s minus 1, so s to infinity. Logarithmic formula, that is log a minus log b, can be written as log of a by b. So log of a by b, s to infinity. This step, this is there, s by s minus 1. Now this numerator and denominator, we are going to divide by s. That is s by s. This is s minus 1 by s. This S by S is 1. This part, the down part, S by S, 1, 1 by S. We will substitute in the place of S the upper limit infinity. So when we are applying, so the log of this is 1 by 1. Here S place we are substituting. So 1 by infinity, it's nothing but 0. So the upper one we applied minus log of 1. This is same as it is minus 1 by S. Here the first one is log 1 we are getting. That's what it is written here. The second one we are taking the LCM and we got it. This one log of LCM S minus 1. It is written. Log 1 is 0. So we got it here. This one log 1 is 0. Here minus log S by S minus 1. More simplification. Log S minus 1. Yes, this minus is removed. That's what it is written. Reciprocal. So now so far we concentrated if the function is multiplied by t divided by t, both we completed. Now derivatives we will concentrate. Using the theorem of transform of derivatives. Find the Laplace transform of following function. That is cos at. So L of cos at. A simple way because it is an elementary function. We know the formula S by S square plus A square. But specifically they told apply this derivatives we have to apply it. Now how to apply this derivatives we can concentrate. We are going to take f of t as cos at and we are finding f dash of t, the first derivative of f of t. So cos at, the differentiation is sin at. Again, cos differentiation we know it is a minus sin at. Again this at we will do the differentiation. That is the coefficient of, we are doing the differentiation t. So the coefficient of t is nothing but a. That should be multiplied. So that's what here it is written. Minus a sin at. And we are doing the second time also derivative. The first time when we are doing, we got it minus a sin at. Now the sign differentiation is cos at. Now the coefficient of t is a. Already minus a is there, so minus a square. It is written. So the two first derivative we did the second derivative. We are not going for the third derivative. What is the reason why we stopped up to why we are doing the derivatives only 2 times? Why not the third time we are not moving? That is a very genuine the doubt which will ring in our mind. Fine. Now, that doubt we will come back. Now, this time being we can accept that 2 times we did. Fine. L of f double dash of t. This is the derivative formula. If it is 2 time derivative it is there, then s square we will start. Then L of f of t minus s into f of 0 minus f dash of 0. Whether we did the formula, we have written the formula in a correct way or not, how we can check it? That is If it is 2 times the differentiation is there, then s squared we will start. If it is third derivative, we will start with s cubed. Fine. S square, s power 1, then s power 0. It is in decreasing order, the s will be there. After writing the formula, we can recheck it. The first one is L of f of t. The second one is f of 0, f dash of 0. If it is here two derivatives, the formula will be end with one derivative. Suppose here 3, the derivative is that if the formula will end with 2. That is here n means here n minus 1. That is the easy way of checking the formula. Now, to substitute in this formula, what are the terms are required? This first, it's okay, fine. F of 0 we want it. That is, our f of t is cos at. So, in this f of t, that is t is taking the value 0. So, we are going to substitute here t plus 0. So, the left side is f of 0 and cos 0. Cos 0, it's nothing but 1. Fine. The next, f dash of 0. So, now here f dash of 0, so minus a into sine 0, it's nothing but 0. Substituting in 1. So this is the first equation. In this, what are the values we got it? We are going to substitute. So f double dash, here we got it. Minus a square cos at equal to this s square L of f of t minus s as it is. F of 0 we got it 1. F dash of 0 value we got it 0. So everything, the values we substituted in this equation 1. The next one is here minus a square L of cos at equal to this one s square L of cos at minus s. So now this minus a square L of cos at, we are bringing minus s square L of cos at equal to minus s. Throughout a minus is there, we cancelled it. Then L of cos at, it is common, we have taken s square plus a square, which is equal to s. So L of cos at equal to s by s square plus a square. So we got it. Now the doubt actually here, why we stopped up to only second derivative. The reason is the question is given cos at. First time we did the differentiation, we got the trigonometric function in terms of sine. But our question is cos. So we are not going to stop. One more time we are moving. Though second time we are doing the derivative, we got actually in terms of cos. Our question also it is matching with that trigonometry. This is a small technique we have to follow it. So that is the reason we stopped it. The question L of cos at equal to s by s square plus a square. So the derivative, the theorem applying, what is the question it is asked, it will fall in the left side. It is not somewhere we are doing the careless mistake, which will give the indication to us we can correct ourselves. So now we completed the derivatives is completed. Now we will concentrate. Suppose the function which is integral, if it is under integral, how to use this Laplace transform. This first we are taking, that is e power minus t cos t we are taking. Finally, we will concentrate about that integration. So suppose the question is only e power minus t cos t. That we are taking as f of t. Again, if the cos t is multiplied by e power minus t, we have to go back our first shifting theorem. The first shifting theorem, it's nothing but any function which is multiplied by e power minus at or e power at, it comes under first shifting theorem. The first shifting theorem, that is the result after applying the Laplace transform, that will be in terms of s. That s will be replaced by, according to first shifting theorem, if it is minus a, s plus a, opposite. If it is plus a, opposite, s minus a. Fine. This is according to formula. Our given problem, e power minus t, it is there. That means here in this place, a place, it is 1, it is there. So L of cos t, so s is replaced by s plus 1. Now cos t, the formula which is available, L of cos at, it's s by s square plus a square. So s by s square plus a square, that is 1 square. So s is replaced by s plus 1. So here s is s plus 1. Here this s square is there. That is s plus 1 the whole square plus 1. So we got it. The numerator is s plus 1. The denominator is s square plus 2s. Here plus 1, here plus 1. Put together s square plus 2s plus 2. It's nothing but L of f of t. That is, we can write it f bar of s. So the question, this part only we completed. That completed and we got the result, this one. Suppose the completed one, if it is again we have to do integral, how to apply Laplace transform. That is, that function f of t, it is under integral. Very simple thing, this f of t, we have to find L of f of t. That already we found it. That is divided by s. Simple integral. That is L of f of t, it's nothing but f bar of s divided by s. So whatever the function, if it is under integral, first L of f of t we have to find. The result will be divided by s. Now, this complete Laplace transform we applied and we got the result, this one. For this, the Laplace, this we got it. For this integral purpose, the Laplace, the rule for the integral is, which is divided by s. So 1 by s. Yeah, we will come to a conclusion of this topic. First, what is a Laplace transform? The definition. Whatever f of t, the function, which should be multiplied by e power minus st, and we have to do the integration with respect to t from 0 to infinity. And we have taken a problem, that is, which is the function, the trigonometric function, which is multiplied by t power 1. This is the formula, that is t power is 1. That is the reason minus 1 power 1. One time we did the differentiation. Next, this f of t is divided by t. Then L of f of t we will do an integral from s to infinity. For this divided by t we have to do it. Derivative, one problem we have taken, that is L of cos at. Cos differentiation sign, again sign differentiation is cos. It is coming back to our question. So f double dash of t, this is the formula. Next, this we have taken e power minus t cos t. This first we concentrated, we found the Laplace transform of this particular one, assuming as f of t. After finding L of f of t, for this integral purpose, the result which is divided by 1 by s. So we concentrated derivatives, integrals, multiplication by t, division by t to the function. We applied the Laplace transforms. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.